Bismillahirrahmanirrahim. Assalamu alaikum dear students. This is our next problem. This problem has again been selected from the book Modern Physics by Kenneth S. Crane. Okay. This problem has three parts. As usual, we first come towards its statement, then we will go to helping tools, and then we will go to solution of this problem. Okay, a Pi-Meson of rest energy 139.6 million electron volt moving at a speed of 0.906 c speed of light collides with and sticks to a proton of rest energy 938.3 million electron volt that is at rest. Dear students, here the wording that is at rest is very important. This is for proton. Okay. Moreover, this rest energy that is 938.3 is also given in the table, which will be used as a tool, helping tool of this problem, so that we can say that even if this value is not given in this problem, we can find this value from the concerned table. Okay. A Pi-Meson of rest energy 139.6 million electron volt moving at a speed of 0.906 c, where c is speed of light, collides with and sticks to a proton of rest energy 938.3 million electron volt that is at rest. So dear students, here two rest energies are given, one speed is given. Okay, and it is given that the colliding particle, that is proton, is at rest. So in case of rest, momentum is zero. Part A of this problem is that find the total relativistic energy of the resulting composite particle. Okay, find the total relativistic energy of the resulting composite particle. Part B, find the total linear momentum of the composite particle. Part C, using the results of A and B, find the rest energy of the composite particle. Dear students, here in part A, we have to find relativistic energy of Pi-Meson as well as proton. Okay, then we will add these two and we will get the solution of part A. While in part A, total linear momentum is equal to the momentum of Pi-Meson, because proton is at rest, so its momentum is also is zero. So we do not need to find two momenta and then add them to get the final result of part B. Okay, that is to say, in part A we have to make dual calculations. Okay, one calculation for Pi-Meson and other calculation for proton. But in part B, we have to find the momentum only for Pi-Meson. Okay, we have not to find momentum for proton, because proton is at rest. While in part C, it is said that using results of part A and part B, find the rest energy of the composite particle. Okay. Now we move to helping tools. Okay, helping tools. Tool number 1. Dear students, in tool number 1, total energy of a particle E is given as being equal to K plus mc square, where K is kinetic energy and mc square is the rest energy. Okay, this is alternatively equal to, in the second stage, equal to mc square over 1 minus v square over c square. Okay, where m is the rest mass of particle, c is the speed of light in vacuum, v is the speed of particle, and this factor in the denominator may also be termed as or written as equal to gamma, where gamma is a Lorentz factor relating rest frame of particle and frame of observer. Okay, there is no almost no need of last step. Okay, this is just a rearrangement. Okay, anyhow, in tool number 2 a table is shown. Okay, in this table mass of proton in energy units is given as 938.3. okay, in place of mc square we will use this value. Okay, that is 938.3 million electron volt. If we want to convert it in electron volt, then it will become 938 300 300 and then again 3 times 0. Okay, that is we will multiply it with 10 raised to the power 6 in order to convert it in electron volt. Okay, tool number 3, relativistic momentum, which is denoted by P is equal to mv over 1 minus v square over c square. Okay, where m is the rest mass of particle, v is the velocity of particle, okay, c is the speed of light in vacuum. Okay, we will use this expression for relativistic momentum. Okay, tool number 4, relativistic kinetic energy. This has been taken this perhaps this has been repeated. 37.27. No, this is not repeated. Anyhow, its contents have been repeated. Okay, relativistic energy k is equal to mc square over 1 minus v square over c square minus c square, which alternatively becomes equal to gamma minus 1 into mc square. Okay, actually this is relativistic kinetic energy, this is relativistic momentum, and this is the total energy. Oh, okay. So here, dear students, we need to differentiate among these 3 snapshots. Okay, these snapshots have been taken from the book University Physics by Young, Friedman, Hug. Okay, in tool number 1, total energy of a particle is given. Okay, that is equal to k plus mc square. In tool number 3, relativistic momentum is given. Okay, while in tool number 4, relativistic kinetic energy is given. Okay, not total energy, because total energy is equal to k plus this is k plus mc square. Okay, total energy of a particle E is equal to k plus mc square, but that expression, that is this is only relating to relativistic kinetic energy. Okay, that is relativistic kinetic energy is equal to mc square over 1 minus v square over c square. Okay, where m is the rest mass of particle, c is the speed of light in vacuum. Okay, v is the speed of particle, minus mc square. Okay, minus mc square. On the left side, mc square divided by gamma, but in the right side only mc square. Okay, this alternatively becomes equal to gamma minus 1 mc square. Okay, that is we will take that is this factor as LCM, and this expression will take the form in this form. Okay, tool number 5 is applicable to part C of this problem. Okay, the relativistic linear momentum of a particle is related to its total energy through the equation E square equal to P square C square plus mc square whole square. Alternatively, we are concerned with E. So E will become equal to under root P square C square plus MC square whole square. Okay, whole under root. But actually we are not concerned with E, we are concerned with MC square. Okay, we will see this thing in part C. Okay, now we come towards the solution, and hence the first solution of part A. Okay, let relativistic energy of a Pi-Meson, that is here we denote it by E pi, where pi is written as a subscript of E. Okay, E pi is equal to K pi plus MC square pi. Okay, where K is the kinetic energy of Pi-Meson and MC square is the rest energy of Pi-Meson. Equation number 2, EP is equal to Kp plus MC square P. Okay, that is relativistic energy of proton is equal to kinetic energy of proton plus rest energy of proton. Okay, and in equation 3 both these equations have been added, that is total energy is equal to energy of Pi-Meson plus energy of proton. Okay, we will use these three equations to get our solution. Okay, so first we use equation number 1. Okay, now E pi, okay, energy of Pi-Meson is equal to kinetic energy of Pi-Meson plus rest energy of Pi-Meson. Okay, this is equation number 1, and this is equal to, because here dear students we will have to go to tools, but I think we have visited these tools so many times that now it is equivalent to wastage of time. Okay, so kinetic energy of meson is equal to MC square pi, that is rest energy of Pi-Meson divided by gamma 1 minus V square over C square minus MC square pi, that is Pi-Meson plus MC square pi. What is this? This is actually, dear students, in the expression of relativistic kinetic energy this factor is included, and according to question 1 MC square pi is further added in K pi. Okay, this portion, this is only equal to K pi, and this is the same factor here. Okay, so in place of K pi we have used MC square as a subscript pi divided by gamma minus MC square pi. Okay, plus MC square pi. Okay, this MC square pi is that appearing in equation number 1, while this MC square is in place of K pi. We once again go to that tool where relativistic kinetic, yes, this is relativistic kinetic energy K is equal to MC square over 1 minus V square over C square minus MC square. Okay, so we have applied this expression. Okay, MC square divided by 1 minus V square over C square minus MC square. Okay, and in that equation plus MC square is present as a part of that equation. Okay, this plus MC square Pi-Meson. Okay, hence this is the equation in place of K pi. This factor has become, and plus MC square is that which is appearing in equation number 1. Okay, so subsequent two factors will be cancelled out. Okay, because their signs are only different, their magnitudes are exactly equal. Okay, so we will be left only with MC square pi over 1 minus V square over C square. Okay, dear students, MC square, that is rest energy of Pi-Meson, is given in the statement, which is 139.6 million electron volt over 1 minus V square over C square. V is given as 0.906 C. Okay, square divided by C square. Okay, dear students, here C square will be cancelled out with the C square. Okay, because this is square, this c square will be cancelled out with this c square, and we will be left with 1 minus 0.85. What is 0.82? 0.82. 1 minus 0.82. 0.82 is actually square of 0.906. Okay, if we multiply 0.906 with 0.906, then we will get 0.82. Okay, and when we will subtract this figure from 1, then we will get a figure of which under root is equal to 0.42. Okay, dear students, here we have made two steps simultaneously. Okay, 1 minus 0.82, it means 0.18 will remain, I think, and 0.18 under root of 0.18 will be equal to 0.42. Okay, so no rocket science, we have just simplified this expression, and this simplification falls within the scope of middle or secondary school level. Okay, and hence relativistic energy of Pi-Meson becomes equal to 332.38 million electron volt. Okay, this is the value of E pi. Okay, that is energy of Pi-Meson. Similarly, we will calculate relativistic energy of proton. Okay, here again it will become equal to kinetic energy of proton plus rest energy of proton, equation number 2. Okay, we know that because proton is at rest, so its kinetic energy is 0. So in place of Kp we will take 0, while value of mc square p, that is the rest energy of proton, is also given in the statement, and it is also given in the tool, that is table. Okay, so we can take this value from either of these two sources. Okay, so in this way EP has become equal to 938.3 million electron volt. Okay, this is the same value which is given in the table or tool. Okay, because one factor is 0, and now E equal to E pi plus EP, equation number 3. So when equation number 1 and 2 are added, we get equation number 3, and this is E equal to 1270.68 million electron volt. Now we come towards part B. Okay, part B. Dear students, in part A we have used the philosophy that because proton is at rest, so its kinetic energy is 0. In part B we will use the philosophy that because proton is at rest, its momentum is also 0. Okay, kinetic energy and momentum both are 0 when proton is at rest. Okay, so in part B these three dots denote because or since. Okay, because proton is at rest, therefore this implies that total momentum is equal to P pi. Okay, here we do not need to find out the value of momentum of proton, Pp, which will be denoted by Pp, because Pp is 0, because proton is at rest, therefore total momentum will be the momentum of the Pi-Meson. Okay, momentum of proton is 0. So in part B we have to calculate only one thing. Okay, and we know that from tool, where we have defined expression for relativistic momentum, P pi is equal to mv over 1 minus v square over c square. Here with v we can also write it as v pi, but I think we should not make denotions or notations so complicated. Okay, it is okay quite. That momentum of a pi meson P pi, where pi is written as a subscript of P, is equal to mv over 1 minus v square over c square. Okay, dear students, in the next step we have made an alternate arrangement from ourselves, just to bring this expression in a particular form where we can apply known values. Okay, what we have done, dear students, here we have multiplied and divided it by c square. Okay, if we multiply and divide m by c square, there will be no difference, because c square will be cancelled out with c square. The only purpose of this manipulation, the purpose of this arrangement is that when we multiply it with c, we will get mc square, and we know that value of mc square is given as rest energy, not only in the statement, but at one place that thing is also given in tool or table. Okay, so to the extent of mc square, we have a value which we will put, and our problem will be will be solved in a smooth way. The next part is that in the denominator c square, we have separated it into c into c, because one has we have written below v, that is v over c, and with second multiplied with 1 over c. Okay, yes students, over 1 minus v over c, in place of v, value of v is given in the statement. This is 0.906 c over c square. Here c square will be cancelled out with c square. Now we are in a position to put value 139.6 million electron volt in place of mc square, and in place of v over c we can use the value 0.906, because v is equal to 0.906 c, and c will be cancelled out with c, and we will get the value of v over c as 0.906 multiplied by 1 over c. Okay, to this c we have not disturbed. This c is still existing in the same position. Okay, in the denominator we have used 0.42, which we have already calculated. From where we have taken, we go a step behind. Okay, this is okay, this 0.42. okay, the expression gamma, Lorentz factor, gives us a result 0.42. so here we have directly used this result in the denominator, and hence total momentum p pi. Okay, that's it, that is total momentum, which is equal to the momentum of Pi-Meson, has become equal to 301.14 billion electron volt per c, mev over c. Okay, now part c. Part c, in a tool we have expressed. Okay, we have reserved one tool for this part c, where e square has been given as equal to pc whole square plus mc square whole square. This implies that from here mc square whole square will become equal to e square minus pc whole square. Okay, and then this implies that mc square will become equal to under root of that, because we, in the next step we will take under root of both sides, and hence mc square will become equal to under root e square minus pc square. Here value of e we have calculated in the previous part, which is 1270.68 million electron volt whole square, minus we have also calculated value of pc in the previous part, which has become equal to 301.14 million electron volt. Okay, in the next step we have taken MeV, million electron volt whole square, as a common, and then square of 1270.68 is equal to 1614627.66. Similarly, square of 301.14 is equal to 90685.3. Okay. So after simplification, this will become equal to under root 1523942.36 million electron volt square. And when we will take under root of this, square of million electron volt will be disappeared, because under root is power 1 by 2, and 1 by 2 will be cancelled with 2, and we will get only million electron volt. Moreover, the under root of 1523942.36 will become equal to 1234.48 million electron volt. And this is the result of our part C, and this is the end of our problem. And till next video,